Hello. Let us try to understand the basic concept of a dimmer circuit. Dimmer circuit meaning dimmers used in AC loads for certain kind of a lamp load or any kind of linear load. To sometimes also your fan that we use. The basic circuit is inside this blue box where we have one triac, one diac, one capacitor and one fixed resistor and a variable resistor. This is the basic construction. Of course, there are certain precautions in the commercial type where we use some filters, but we will try to understand the basic function here, so we are eliminating the filter function here. The whole thing is connected in series with the supply, main supply, and of course the load. We have connected a CRO to see the waveform, one across the lamp with respect to ground. Here we have given the ground here, and also with respect to the triggering point. This is the triggering point. Let me explain before we go into see the function. First of all, when we apply the supply, what happens? This capacitor starts charging through this R1 and also this, because this is in series. And in the process, what happens? This capacitor goes on charging to a certain voltage. While the voltage exceeds more than 33 volts, we have a diac here, and we have used a 33 volt diac. And once it crosses the 33 volt, this starts conducting, because we know diac is a bidirectional device based on its voltage. So once the voltage crosses, it triggers, and once it triggers, it starts conducting through the gate, and then gate is triggered. In the process, the triac triggers, and the triac triggers means since the load is connected in series with the entire circuit, the load starts switching on. Now the point is how the delay is made, or how the intensity of this lamp is varied. The intensity of this lamp is varied based on the timing of the switching of this triac, which we will see in real time while we switch on the CRO, and we will get it to more information. But the basic concept is this. Now if we reduce this, now this 100k or whatever the value here is bypassed. Now if we reduce this to say certain level, what happens? Now this resistance comes into picture also. Earlier there was no resistance, since this was sorted by this variable link. Now this resistance comes into picture with series of this. Now that means the resistance value goes on increasing. Once the resistance value goes on increasing, the charging time also takes longer. And mind it, this time is, we are talking about in milliseconds based on the frequency of the supply. Now supposing my frequency is 50 Hz, or in places like US it is 60 Hz. So based on that 50 Hz or 60 Hz, we are talking about that time only. That one cycle for a 50 Hz will be 1 by 50, that is one cycle is 20 millisecond, whereas one half cycle is 10 milliseconds. So what we are talking about is a 10 millisecond time duration as far as the delay of this triggering is concerned. All these will be clear once we go over to the simulation and see the function. Now let us see what happens. We see the storage oscilloscope, digital storage oscilloscope connected here. This B channel is connected to this place. That means we want to see the triggering point, and this yellow line what you see is across the lamp. This is the waveform at the moment across the lamp. We have taken 1 millisecond duration graph here, so that we find this is 10 millisecond and this is 10 millisecond, which is 20 milliseconds as regards to 50 Hertz. And what we find is the diac is conducting at 33 volts. Now see, this is the 20 scale. What we have here is 20 scale as far as this is concerned, the 20 volt scale, and when it crosses 30 volts, it starts triggering. It starts conducting. It starts conducting. At that point, the triac conducts, and in the process we get this waveform, little cut from the 0. This is the 0. And as we go on, say, increasing the resistance, so what you see what is happening, it is taking longer time. Well, the waveform gets inverted because of the simulation software. That's the different point. It has taken longer time. Earlier it was triggering at this point. Now it has taken longer time but the voltage same. Once it crosses more than 33 volts, it starts conducting, and in the process the triac triggers. This happens for both the cycles in a similar way, and let's call it a positive cycle, negative cycle. It's only a matter of name that we give, but it's one of the cycle. Understanding one of the half cycle is good enough to understand the whole circuit. Now we go on still in increasing the resistance. You see, we still go on increasing the resistance. What happens? We go on increasing the resistance. What we notice is it is still taking longer time. You see, that blue line is still taking a longer time to reach the 33 volts. Because of that, okay, we can pause it here and then can see it better. Yeah, it is taking still longer time. In the process, it triggers delayed by this much of time. The total time is 10 milliseconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now nearly about 5 milliseconds delay. Because of the 5 millisecond delay, we find the waveform is almost at 90 degrees triggering. And if we go on further, reducing the or increasing the resistance, you find the time is still increasing, and in the process, as the time goes on increasing, as we noticed, as the time goes on increasing, the delayed firing also goes on increasing. In the process, the power to the load gets reduced. And that is how we find that the lamp is operating with a lesser intensity. Let's see it again. And once we again come back with the cutting the resistance, that means the C charges faster in the sense earlier than the 5 millisecond which we have noticed here. Now let's see, when we come to the full waveform, what we find here. Once we come to the full waveform, what we notice here is within about say 1.5 millisecond, it has reached 33 volts. Because it has reached 33 volts, this has triggered it. This is how the whole circuit operates. We have just tried to explain only one half of the cycle. Exactly the same thing happens with the other half of the cycle. But there are many precautions which are to be taken for this kind of circuit, where you have to select the kind of triac that you want to use, because the certain triacs require a very high gate current. And then there is a quadrant problem, we call it fourth quadrant and second quadrant problem, where those are matter of more theoretical subject, where the gate requires more current as compared to first quadrant, and in first quadrant and third quadrant the current requirement is less in the gate to this terminal, whereas in the second and the fourth the gate current requirement is high. Those are all matter of little more theory. We will not go into more details of that. Thank you.